Here we're asked to determine the largest open intervals of the domain over which the function is increasing, decreasing, or constant. And so they've given us the graph of the function, and we're looking for where over its domain is it increasing, decreasing, or constant. So I'm going to redraw the graph just so I can have it that I can mark on it. And so it looks something like this. And this point over here is -3, 9, and this point down here is +3 and -9. And so we're asked the largest open intervals of the domain over which it's increasing, decreasing, or constant. When we're looking for increasing, decreasing, and constant, we read the graph left to right. We're looking over its domain. And so over the x values, the x-axis, starting here at the left, and we read it to the right. And so starting over at the left, we're looking for where is it increasing? Well, it's increasing if it's going up. We're looking for where is it decreasing? That would be where it's going down. And where it's constant would be where it's flat. It doesn't go up or down. There's no change. It remains the same, constant. And so we read the graph left to right from negative infinity to positive infinity. So negative infinity over here where we start, positive infinities over here where we end. And so when we're looking for increasing, decreasing, or constant, we're looking at what are those y values doing? Are they going up or down? But when we report those intervals, we're looking for where is that happening? And the where is determined by the x-axis, so the domain. And so we're looking for where the function is increasing, and so we report that in terms of x. And when it says open intervals, it means we're going to use parentheses for all of these. We're not going to use brackets, even if some may warrant brackets. We'll always use parentheses because they want open intervals. And so we noticed from looking at this graph, reading it left to right, it's increasing first, and then it decreases here in the middle, and then it increases over there at the end. It's going up over here. It starts all the way at negative infinity. And so all the way as far as we can go on the left, so negative infinity. And then it's going up from there all the way to this point. And so this point, notice, occurs on the x-axis at -3. So the function is increasing over that interval from negative infinity to -3. And then we notice at -3, it switches from increasing to decreasing. The graph starts going down, and it goes down all the way from that point to this point. So from -3 all the way to here, +3, it's increasing. Sorry, decreasing. It's going down. So from -3 to +3, let's put that over here a little, it's going to be decreasing. It's going down. And then at +3, it starts going back up. And so from +3 all the way to the end of the number line, to the end of its domain. So all the way to positive infinity, it's going to be increasing again. So when we're reporting these intervals, open intervals, so we're using parentheses, and notice we've got the entire domain covered, the entire x number line from negative infinity to -3, -3 to +3, and +3 to positive infinity. And so those values are the intervals. It's increasing in that first one. So it's increasing from negative infinity to -3. From there, it starts decreasing. It's decreasing from -3 to +3. And then from there, it begins increasing again. And so it's increasing from 3 to positive infinity. So we have two intervals where it's increasing, the first here and the last one here. We only have one interval where it's decreasing. That's the one there in the middle. And this graph isn't constant anywhere. So now we just need to put those into our answer boxes. So on part A, we're asked about where the function is increasing. On option A, we can enter the intervals, or we can select option B, it's never increasing. Well, it is increasing, two different intervals, so we're going to select option A. And then we can see in our toolbox, we've got the parentheses, the ordered pair, the interval, we can use that as an interval. And so we've got to put in our negative infinity. And so we need my keyboard again, so I can do the negative and then back to the toolbox for the infinity. And then I'm going to arrow over to the blue box and put in the -3. And then it's already got the closed parentheses, so I can arrow over after it. And then we're separating those with a comma. So comma, and then I'm just going to use the keyboard this time to open the parenthesis and then put in the +3 and then to positive infinity back on the toolbox. And then I need to close that parenthesis, so back into my keyboard to close the parenthesis. And so now we can see that it is increasing from negative infinity to -3 and from +3 to positive infinity. On part B, we're looking for where is the function decreasing. We've got one interval where it's decreasing, so we're going to select option A. And we're going to put the interval from -3 to +3. Again, you can either use the ordered pair button in the toolbox, or we can just do the parentheses on the keyboard. And so we get -3 to +3, close those parentheses. Oops. And then on part C, it's asking for where the function is constant. The function is never constant, and so we select option B, the function is never constant.